You know, usually when we picture a massive global corporation, there's a very specific soundtrack attached to it for you and me.
Oh, absolutely. The ambient noise of the office.
Right. You have the clacking of keyboards, the murmur of Zoom meetings in the background, and like the endless anxiety-inducing pinging of Slack notifications.
Yeah, which is basically how we reassure ourselves that work is actually happening. We hear the friction, so we just sort of assume progress is being made.
Exactly. But I want you to imagine walking into the headquarters of a highly profitable multinational enterprise, and it is completely silent.
Eerie, right?
Very. I mean, there are no desks, there are no employees, no break room coffee machine, just rows of glowing servers quietly executing complex financial strategies.
They're negotiating global contracts, launching viral marketing campaigns, all of it.
Yeah, it's an entire organization made completely out of code.
Which is the absolute definition of a zero-human company. And,
Yeah.
what's staggering about the materials we're looking at today is that the architecture to build this, it isn't science fiction. It's actually already here.
And that's exactly what we're digging into today on this deep dive. I'm your host, and joined by our resident expert, we have a massive stack of source materials in front of us.
You really do.
We are talking architectural blueprints, technical system manuals, UI mockups, and audio transcripts detailing a protocol called Denarii DFi.
Along with a system known as the Paperclip AI Orchestrator.
Right, and the broader global shift toward what these architects are called the agentic economy.
Which represents just a fundamental evolution of the internet. Because, for the last decade, we've been obsessed with the speculative, token-driven era of Web3.
All the hype and memes.
Right. It was all about who owned what digital asset. But these blueprints point to something entirely different. They point to a machine economy.
So our mission today is to unpack this massive structural shift for you. We are looking at a reality where entire companies can be run autonomously by AI agents.
Okay, let's unpack this, because the very first concept jumping out of these blueprints is, honestly, incredibly humbling.
I know exactly what you're going to say.
Human involvement, like our decision-making, our oversight, is suddenly being viewed as a liability. They actually call us a bottleneck.
Yeah, it hurts the ego a bit, but that's the core thesis of the agentic economy. They define human latency as economic leakage.
Economic leakage.
Think about it. If an enterprise system requires a human to click an approval button or, review a spreadsheet or even just read an email before moving forward, that delay degrades the efficiency of capital.
Because the philosophy here is just simple, right? Execution beats narrative.
Exactly.
The old internet felt like a static digital library where we passively read things, or, I don't know, maybe a digital mall where we clicked buy.
Sure. Very transactional, but slow. Right. But this new version is an automated factory executing decisions while we sleep. And to replace us in that factory, these blueprints introduce something called the Paperclip AI Orchestrator.
And we should clarify, it doesn't treat AI like a friendly chatbot that helps you write emails. It's completely different.
Yeah, it organizes different AI models into rigid, traditional corporate hierarchies.
Right. You are looking at an organizational chart where a CEO agent sets the high-level strategy. Below that, an engineer agent writes the code, a quant agent runs the financial risk models, and a QA agent audits the entire process.
It's mimicking a corporate structure, but entirely removing human latency. And when you look at the operational overhead they're targeting, the cost savings are staggering.
Unbelievable, really.
I saw the orchestrator breaks this down into the 5 pillars of enterprise automation. But give me a sense of the scale here. How much are we actually talking about saving when AI takes over these massive human platforms?
Okay, so let's look at Pillar 1, which targets social and marketing. Traditionally, you'd pay for a PR agency and software suites like HubSpot.
Which gets expensive fast.
Oh, very. But under this new model, a dedicated social agent runs 24/7, scraping trends and engaging audiences autonomously.
Right.
The blueprints estimate that single replacement saves over $8,000 a month.
And it never takes a vacation.
Never. No sick days, no weekends. Then you look at Pillar 3, which goes after the treasury. A treasury agent replaces premium, human-operated blockchain analytics tools like Dune or Nansen.
Well, I've used those. They're not cheap.
Exactly.
Yeah.
And this agent constantly monitors liquidity pools and executes arbitrage trades in real time. That's another $5,000 a month in savings.
Oh, wow.
But the most disruptive is definitely Pillar 5 project ticket and delegate orchestration.
So this is going after management software like Jira or Asana. I use those every single day. How does an AI not just create the ticket, but actually do the management?
Well, instead of a human product manager writing a ticket that says, build a new login page, the AI CEO identifies that a new login page would increase revenue.
Okay.
It breaks that goal down into highly specific engineering tasks,
Mm-hmm.
assigns those tasks to the specialized engineer agents based on their current workload, and then tracks the velocity of the code being written.
So it's doing the thinking and the managing.
Right. They estimate that removing the human operations teams alone saves over $100,000 a year in overhead. What's fascinating here is that coordination is the new currency.
Makes sense of that for me.
For the last 10 years, the competitive edge was having access to information. But in a post-interface economy, the edge is orchestration.
Ah,
The real trillion-dollar systems of the future won't have flashy user interfaces or apps you download. They will be completely invisible infrastructure, operating entirely below the surface, optimizing value flows with zero human friction.
wait, I'm getting stuck on a massive logistical hurdle here.
Okay, what is it?
If these AI agents are acting as autonomous corporate entities, they need a way to manage capital, right? A CEO agent can't exactly walk into a local Chase branch, show a driver's license, and open a corporate checking account.
Obviously not, yeah.
It can't sign a lease for server space. So what are the actual financial rails these machines run on?
Oh, they require a multi-chain ledger system. Traditional banking rails simply aren't built for machine-readable, machine-executable value transfers at API speeds.
Because legacy banks take days to settle a wire transfer.
Exactly. So the Denarii DFi blueprint calls for something they term the Trinity of DLT, or distributed ledger technology. They weave together three specific blockchains to solve the infamous blockchain trilemma.
Which is balancing speed, security, and scalability, right?
Correct.
So they aren't just using one network to do everything.
No, because one network can't do everything perfectly. First, they use the XRP Ledger, specifically because it offers sub-second speed and massive deep liquidity.
Because when machines trade, latency is death.
Exactly. Second, they layer on Algorand for something called mathematical finality.
Why does a machine care about finality? I mean, I swipe my credit card and the coffee is mine. Isn't that final?
See, human systems tolerate ambiguity. Machine systems cannot. In some blockchains, there's a risk of a fork, which essentially means the network temporarily splits into two different versions of reality.
Oh, right. Like two timelines happening at once.
Exactly. If you're a human, you might just wait an hour for the network to resolve it. If you're an autonomous machine executing thousands of trades a second, you cannot function. If you have to second-guess whether a $1 million payment actually cleared or if the network might roll back to a previous state.
That would be a nightmare for an automated treasury.
It would ruin it. Algorand's pure proof of stake means there is zero fork risk. Once a transaction happens, it is mathematically permanent instantly.
That makes sense. The machine needs an absolute ground truth. And then the third part of the Trinity is Hedera Hashgraph, which the manuals say is for massive throughput and verifiable audit trails.
Which is the crucial bridge to the human world.
I'm glad you brought up the human world because I'm hitting a wall here. I can see the AI making these split-second trades on Algorand or XRP. I understand the tech.
Right.
Wait, I get the tech, but how does an enterprise CFO actually trust an AI with real spending authority without triggering a massive compliance disaster?
That is the million-dollar question.
Because if I'm an enterprise CFO running my company on traditional software like SAP or Oracle, I can't just have rogue code sending corporate funds across international ledgers. The SEC would have a field day. It sounds like a massive compliance disaster waiting to happen. How are they not getting sued into oblivion?
If we connect this to the bigger picture, you've just identified the exact reason why traditional crypto has basically been ignored by Fortune 500 enterprise finance.
Right, the lack of traditional compliance.
Yes, and it's exactly why these blueprints introduce a critical piece of middleware called the AFTL, the Agentic Finance Translation Layer.
So the AFTL acts like a real-time translator between the chaos of the crypto rails and the rigid, heavily regulated rules of corporate accounting.
That's a perfect way to describe it.
But how does it actually do that without exposing all of the company's secret financial strategies to a public blockchain?
It uses zero-knowledge proofs. If you're not familiar with the concept, think of a ZK proof like a bouncer at an exclusive club who can mathematically verify you are over 21 without ever looking at your actual ID.
Oh, so they don't see your name or know your address.
Precisely. The AFTL intercepts the raw, on-chain data from the AI's trades. It uses these ZK proofs and a crypto-native ledger system called token books to instantly translate that chaotic blockchain data into a traditional double-entry accounting format.
Debits and credits.
Exactly that, debits and credits. It then syncs that sanitized, mathematically proven data directly into the enterprise's ERP systems, like SAP.
Okay, so it bridges the gap.
Right. Every single autonomous move the AI makes becomes a verified audit trail that a human compliance officer can actually read without exposing the proprietary trading logic to the public.
Okay, so the corporate structure is built, the financial rails are safely connected to human accounting, but I'm getting stuck on something else.
What's that?
We're giving these agents the keys to corporate treasuries, but every time I use a large language model, it forgets what we were talking about 20 minutes ago.
Yes. The memory issue.
Yeah, how on earth does a CEO agent run a long-term strategy for a company if it has the memory of a goldfish?
The blueprints address this directly, actually. They call it the memento man problem, referring to the stateless nature of large language models.
Right, because by default, an LLM wakes up with absolutely no memory between prompts.
Exactly. Every single time you ask it to do something, it is essentially being born for the very first time. It has immense capabilities, but zero situational context.
Here's where it gets really interesting. It's like having a brilliant, world-class executive who gets complete amnesia every single night.
That's a terrifying thought for a CEO.
Right. So to fix this, Denarii uses two very specific mechanisms. First is the heartbeat check-in.
Which functions like a mandatory morning briefing. Before the AI can take a single action on the network, it is forced to read a compressed brief, reminding it of its persona, its overarching goals, and its strict definition of success.
But a morning brief isn't enough to run a company. I mean, it needs to know what happened yesterday or last month. That's where they introduced the PRA memory system projects, areas, resources, archives.
Yeah, the PRA system.
It's essentially a highly organized, color-coded filing cabinet that the amnesiac executive can instantly search.
And the architecture here is brilliant because of token limits. An AI can only process so much text at once.
Right, you can't just feed it a 1,000-page history book every minute.
Exactly. The PRA system uses vector databases to only retrieve the specific historical context relevant to the immediate task, rather than trying to force the AI to read its entire life story every 5 seconds.
Which would be wildly expensive anyway.
Oh, absolutely. But without that structured retrieval, the AI loses the plot entirely. And the cost of losing the plot in a machine economy is mathematically terrifying.
Yeah, the manual breaks down the danger of something they call the measurability gap, and it's a stark warning.
It really is.
It basically argues that automating cognitive tasks is getting so cheap that executives will be tempted to deploy unverified AI systems just to cut costs. But unverified AI degrades incredibly fast.
The math they provide is sobering. Imagine an autonomous task that takes 10 steps to complete. Let's be generous and say your single AI agent has a 95% accuracy rate for every individual step.
95% sounds amazing. In school, that's a solid A.
On paper, yes. But in an unverified sequence, errors compound. 95% to the power of 10 steps yields a final success rate of just 59.8%.
Hold on, so you're telling me it basically becomes a coin flip on whether the entire operation succeeds or catastrophically fails?
Pretty much, yeah.
You would be fired instantly in a traditional firm if your department had a 40% failure rate. You certainly can't run a global financial treasury on those odds.
You absolutely cannot, which is why the Denarii architecture violently rejects the idea of a single, all-powerful God mode AI.
Okay.
Instead, they mandate an independent QA agent, a quality assurance model whose sole existence is to audit the intermediate steps of the primary agent. It checks the math before the action is executed.
And by having that second agent verify the first, that compounding error rate resets.
Yes.
The manual shows that the probability of an undetected error slipping through both agents drops to just 0.25%. It goes from a coin flip to highly reliable enterprise-grade execution.
This raises an important question for anyone designing these systems. Why are human architects forced to enforce multi-agent verification loops?
Why not just build a better single AI?
Because intelligence naturally requires friction. It requires a system of checks and balances. The agent council framework they use actually forces different AI personas, like an AI developer, an AI marketer, and an AI economist, to actively debate a strategy before any capital is deployed.
That friction prevents single model decision bias.
Exactly.
I love that visual. You actually want the AI economist aggressively arguing with the AI marketer about the advertising budget before the AI CEO signs off on the
It's
transaction.
corporate drama, but played out by algorithms.
Right. But with the stakes being this high and the math being that unforgiving, how do humans safely test these agents? I assume you can't just deploy a newly minted experimental AI directly onto a live financial ledger and hope it doesn't accidentally bankrupt the company.
No, doing that would be catastrophic. You need a highly controlled environment, which is why the architects built the machine economy simulator, commonly referred to as the agent sim game.
Oh, right. The agent sim game.
Acts as an educational sandbox embedded directly into the orchestrator.
It sounds like a video game. I read it uses a holographic physics graph so users can visually watch the streams of capital flowing between different agent nodes.
Yeah, it's highly visual.
You can physically see how tweaking the parameters of a security auditor agent impacts the overall treasury.
But it's not just a passive, pretty visualization. It is an active, highly aggressive stress test. They integrated a live LLM to act as a dungeon master.
Like in Dungeons and Dragons.
Very similar. But instead of throwing a dragon at your party, this AI dungeon master actively tries to break your financial system by injecting synthetic corporate crises.
Wow, I read it throws simulated flash loan drains at your treasury.
Oh, yeah.
And for anyone listening who is unfamiliar, a flash loan is a crypto mechanism where someone can borrow millions of dollars without collateral, use it to manipulate a market price, steal funds, and repay the loan all within a single second. It's an incredibly complex attack.
And the dungeon master will hit your simulated company with one out of nowhere. Suddenly, your simulation's treasury crashes, the dashboard flashes red warnings, and you, the human user, are forced to generate emergency AI mitigation scripts to patch the vulnerability before the simulation goes bankrupt.
That is intense.
It's training human operators to manage economic physics. It teaches you that building in the machine economy is really about architecting trust and managing risk before you ever touch a single cent of real capital.
That sounds infinitely more stressful than a normal Tuesday at a human office job.
Oh, for sure.
But they are trying to bring a lot of people into this ecosystem to learn these skills. They highlight an initiative called 1 Million Devs. It's a no-code Web3 builder platform that pairs Google AI Studio for the intuitive front end with a system called anti-gravity for the back-end infrastructure.
And the stated goal is to democratize this technology.
Right, turning anyone into a founder by letting them deploy these complex applications with drag-and-drop simplicity.
They do want to democratize the building and simulation process. But make no mistake, they are incredibly strict about who actually gets to take the training wheels off and control the live mainnet infrastructure.
Which brings us to the actual access requirement. To enter the live Paperclip AI Orchestrator and deploy these autonomous agents onto the real networks with real money, users are subjected to a cryptographic token gate.
Yes, a very high barrier to entry.
You have to mathematically prove on-chain that you hold at least 2% of the total DFI token supply. So what does this all mean? Does requiring a 2% total supply holding mean this self-operating internet is destined to become an exclusive walled garden? Are we just replacing human bottlenecks with wealth bottlenecks where only crypto whales get to own the automated future?
It's a very valid concern to have when you first see that requirement. It highlights the constant tension between radical decentralization and actual system security.
Because 2% of a global supply is a massive amount of capital.
It is. But from a purely architectural standpoint, this isn't about elitism. It is a strict Sybil resistance measure.
Sybil resistance, meaning preventing one person from creating a million fake accounts to overwhelm the network.
Precisely. In a decentralized network, you have to prevent bad actors from spinning up millions of malicious AI agents. By requiring a massive 2% stake, the protocol ensures that anyone commanding this incredibly powerful autonomous infrastructure has real mathematical skin in the game.
So they have something to lose.
Exactly. It transforms the token from a purely speculative trading asset into an earned utility key. Think about the incentives. If your AI agent makes a malicious move or tries to attack the network, your own 2% stake, which could be worth millions of dollars, is instantly at risk of being destroyed or slashed by the protocol.
It's essentially mutually assured destruction for bad code. It aligns the incentives of the human operator, the machine workforce, and the network itself.
It secures the perimeter of the machine economy. You cannot wield that much automated power unless you have an equal amount to lose.
That leaves us with a tremendous amount to process. For everyone listening to this deep dive right now, I want you to evaluate your own daily workflow tomorrow.
Yeah, take a hard look at it.
Look at the software suites you log into. Look at the repetitive tasks you manage, the approval chains you wait on for days. Ask yourself, are those processes truly essential to the creative value you bring to the table? Or are they just structured inefficiencies?
Human latency waiting to be optimized away by an AI agent.
Exactly. It is a profound psychological shift to consider. We are rapidly moving from a world where we command software to a world where we merely orchestrate autonomous intent.
But if we extrapolate the blueprints we've looked at today into the near future, it leaves us with a rather chilling scenario to mull over.
Oh, what's that?
If these zero-human companies are constantly seeking optimal execution and ruthlessly minimizing latency, what happens when an autonomous AI CEO from one company enters into an aggressive financial dispute with the AI CEO of a rival company?
Oh,
Imagine a corporate war being executed at API speeds, optimizing and counter-optimizing capital across global ledgers in the middle of the night, long before a human operator even wakes up to realize a conflict has begun.
a silent war fought entirely in the dark. It brings us right back to that image of the empty corporate headquarters. No yelling, no panic in the boardroom, just the quiet hum of servers executing strategies at the speed of light, fundamentally redefining what it means to do business. We'll leave you with that thought.